The goal of this video is to solve two sides of a quadrilateral. I'm making this for a buddy of mine. What up, Sam? And my previous one I ran over time, so I'm going to go ahead and try to be speedy about this. Our goal is to find capital A and capital B here. And so one of the first things that we could do is to draw a dotted line right here, the diagonal, and solve for this diagonal. We're going to use the law of sines. So law of cosines. It's like the Pythagorean theorem. So it starts off with, we'll call this A, we'll call this side B, and we'll call this side C. So A, B, and C are side lengths. A squared equals 12 squared plus 96 squared minus 2 times 12 times 96 times the cosine of the angle between them, which is 95. And if we solve for A, eventually we'll get A squared equals 9,560. Let's just write that out. 9,560 square root both sides. We'll get 97.78, which is that side. Cool. From here, we're going to jump right to the law of sines. Because if we're going to use this triangle, eventually we need to know what this angle is. It's not 110 anymore, and that's not 93 anymore because this diagonal is cutting them. It's not even bisecting them. It's just cutting them randomly. So we got to solve for what this is right here. So we're going to go ahead and use the sine of 95 divided by 97.78. So the sine of this divided by this is going to equal the sine of this, let's call it E, sine of E divided by this. And we'll have to use inverse sine to be able to solve for this thing. Again, I can kind of explain that more in a subsequent video. But if we solve for E, then we're going to end up getting about 7 degrees. And finally, if we know that this is 95, this is 7, this, and this should add up to 180. So that's going to tell us that this should be 78 degrees here. That allows us to then say 93 minus 78, this angle here should be 15. And if that's 7, subtract 110 minus 7 would get us that this angle is 103. Okay. We're going to use the law of sines again, and this time, law of sines, same thing. You just take the sine of any angle, so like 62, for instance. So sine of 62 divided by the side length opposite of it. Set that equal to the same thing, right? Like let's use sine of 103 divided by its side B, but we don't know B. And so we can isolate it, cross multiply, get B all by itself here. We're going to find that B is 104.06 inches. So we just solved what that one is. And then lastly, we're going to use law of sines one last time again. And we're going to say, start off the same way, sine of 62 over 97.78. Sine of that divided by that is equal to sine of this, which is 15, divided by its opposite side, which is A. I don't know that I've solved this one out, so let's just double check it. We could do it with the TI calculator. We're going to do sine of 15 divided by that. And then all of that divided by sine of 62. Nope, that's not right. Let's see that over there. Oh, sorry, these are going to be multiplied. That's why. 97.78 times sine of 15, then divided by sine of 62. And that's 28.66. is this side here. So eventually we found this is 28.66 and this one's 104.06 inches. Cool. I hope that was helpful. Later, y'all.